Today we're going to talk about test containers for YugabyteDB applications. My name is Alex Shalaev, and I work as a developer relations engineer at AtomicJar. AtomicJar is a startup made by the maintainers of test containers. That's why I'm here today. You can find me online if you want to ask any questions and you don't have a chance to ask it right now. I almost universally go by the handles that you can see on the screen. So let's get into it. AtomicJar offers a number of things. The main product are the open source test containers libraries. They give you the programmatic ability to create, configure, use, manage the lifecycle of any services in containers. And there are some helper services around that make developers' life easier so you can use test containers more effectively. There is a free test containers desktop application that you can use for some developer tooling around test containers. And there is a platform as a service Test Containers Cloud, so you can run your containers during a test if you prefer to do that in the cloud. So we're going to talk a little bit about those last two, but mostly about the open source libraries right now. They're available in different languages. There is Java, there is Go, there is Node.js, there is .NET, there is Python. I'm going to concentrate on the Java version because that's where my experience comes from. But you can use the same things in the other languages as well. So let's get started. Tests are essential. Our applications need to be verified, the behavior of those. And it's really, really hard to do that lately specifically. Because if you have this mental image in your head about how to organize the tests, where you cover everything with unit tests, which would test your application components in isolation, and then you cover integration tests on top of that, that would just supplement your unit test strategy and will be harder to maintain, and then they'll be slower and everything. And then you have a little bit of end-to-end tests that run in production environments similar to production. Then this is the picture and the model that is not working very well for our deployments nowadays. With applications relying more and more on third-party services and the behaviors of the systems being encoded in the larger fleets of microservices or in the combination of how services work together, relying on unit tests alone usually doesn't give you enough confidence in your test suites. And ideally, your test suite should give you the high levels of confidence for what's the quality of your application. If your tests are green, the application should be working. If the tests are red, well, your application, it should mean that your application is broken. You should not tolerate the condition where your tests are flaky or like green one day, they red the other day, because then you're actually losing the main purpose for running and writing the tests, assessing the quality. So lately, the idea is to move away from the unit tests for most normal applications and rely on the integration tests as the backbone of the test suite for our services. There's still, you need some integrated tests that run in environments similar to productions, but for your CI needs and for your developer needs, you can rely on integration tests more and more. And why is that move happening? Is because in the past, for the integration tests, we relied on approaches like mocking the external dependencies or installing everything locally, which was error-prone, hard to handle universally across the team, fairly difficult to implement consistently in your local environments and CI, and that just didn't work very reliably. Then we started containerizing the whole development environment, which wasn't the best tooling for developers because, well, I, and I hope you as well, want to use your local tools that you're very professional and productive with. But after that, Docker came. And since Docker and Docker Compose, we could encapsulate just the parts of our environment that we needed in the containers, and your tools and your application could run locally. So they still didn't offer enough flexibility for normal integration testing scenarios, because you could normally just start a single version of your database or of your environment with them. But if you would use Docker API, then you can programmatically create any environment that you want for your local development or for tests. That is what Testcontainers libraries, or that's exactly what Testcontainers is doing. Testcontainers gives you ability to write your unit tests and run them with real dependencies, with the real services. You can put Yugabyte database in the container. You can manage it as a piece of code from your tests or from your application lifecycle code. And the setup works absolutely brilliantly. Testcontainers is not just for Yugabyte, of course. You can run anything that runs in Docker container with Testcontainers. You can run your databases, you can run your message brokers, you can run your Kafka, you can run your Elasticsearch cluster, you can run even the browsers if you want to run sort of end-to-end UI tests in your applications. And as I said before, the implementation of Testcontainers libraries are available in different languages. On top of that, just not run anything you can run in the Docker container with the lower level API. Testcontainers features the whole ecosystem of modules, which are predefined abstractions, libraries that you can put into your project, and you will get the knowledge about how to run particular technology in Docker containers with Testcontainers. You don't have to know how to run MongoDB in a container or Yugabyte. That knowledge is given to you by the maintainer of the library, and you can override the configuration if you want, but the basics are there, and you can instantiate the services in just a few lines of code. On top of that, some modules are marked as official, which is the collaboration between the AtomicJar team and the vendor team. For example, YugabyteDB. The module for YugabyteDB for Testcontainers is not only, it doesn't only encapsulate the best practices for integration testing that Testcontainers team knows and installs into the libraries, but it also comes with the knowledge of Yugabyte. So you know that you get the best of both worlds. You know the Yugabyte team contributes the information about which features needs to be exposed, which convenience API should be there, and so on. And the Testcontainers team tries to make it as good as any other module and keep the bar for the integration testing practices very high. Let's take a look. If I go to my IDE, this is my normal sample Java project. It is very simple. In my POM.xml, what I add my Yugabyte database JDBC driver so I could connect to my Yugabyte database, and I add the Testcontainers dependency on YugabyteDB module. Those come from Maven Central, so you can pull them, and it works brilliantly. After that, what I can do in my test, I can start writing my my configuration. So I'm going to use the Yugabyte container type, and I can say Yugabyte, and I just need to say new Yugabyte container and give it the string, which is the Docker image name for my container that I want to run. You can run anything that is a Docker image. You can use your private Docker registries. You can have the even more configuration, but in a nutshell, you get this Yugabyte object that you can work with. What you can do immediately with it, you can explore what it offers you. So when I do Yugabyte, you can see that I have the, of course it needs to be within the method. I can do Yugabyte start, or I can do Yugabyte stop. So I have the lifecycle methods available to me immediately, and I can get some convenience API. So when I want to configure my test to talk to this particular Yugabyte instance, I can, for example, get the JDBC URL in a single method call. I can, of course, also, let's make it a test. Assert true Yugabyte is running. And well, this actually looks like a proper solid test. I can run it now. Let me run it and then talk about what is happening right now. To run the test, the only thing that I need to have is the compatible Docker environment. Testcontainers libraries, when I run my tests and when I instantiate my containers, will go and find the Docker environment that it deals with. It could be your local Docker environment. It could be Testcontainers Cloud. It could be your open source Docker alternatives like Podman or OrbStack or Kalima or whichever Docker compatible environment you want to use. And then after that, Testcontainers will, if necessary, pull the Docker image if it's not available in the cache, and then create the containers and give you the options to connect to those and run with them. This is a very simple configuration, but you can do more things on that. You can configure the Yugabyte instance with anything you want. You can, for example, override the environment. You can specify which ports you want to expose to the outside world from your host machine. You can override the command if you want to override the command. You can copy files to the containers if you will. A lot of that knowledge is already available from within the library. So here you can see that the library comes with a predefined common sense defaults that you can overwrite if you want, but you don't have to specify all of it manually. What you can do is maybe an interesting configuration. Let me just replace this with a more sophisticated version for a second. What do I do here? I run my Yugabyte database. I run the same Docker image. I copy a string to the container file, populating the container path for PG pass, and I copy my schema file into the container as well. This is how you normally would configure the services, and this is how you can put the dump of your SQL files into the database. So my schema file is very simple. It just creates the table and runs it. So after the container starts, I can programmatically, for example, execute my command, which is the Yugabyte SQL shell script, and say, oh, run that schema SQL file for me. And after that, I will have my data initialized in the database. I can run this and it will run properly the same way as well. So while my test is running, let me quickly look at the Testcontainers desktop application. There are a couple of things that allow me to run this on my Mac locally. This is an M2 Mac with Apple Silicon that is maybe not the most easy to, like as a deployment target, to run your Yugabyte Docker container. What I'm using the free Testcontainers desktop application. And it comes with a couple of things that I want to show you to simplify working with Testcontainer setups. One, I can choose between running on a Docker runtimes or local Docker runtimes or using the Testcontainers Cloud. I'm going to use the Testcontainers Cloud because that runs on the Intel Linux and not on the ARM machines. So there are no incompatibilities between different desktops or CI environments and Docker images that your tests are running. So this is one. And then the other, it packs also a couple of features that are very, very useful for working with test containers. This is the Mac, and by default, if you run this Yugabyte container, what it does, it runs the Yugabyte D binary. So it doesn't create the complex setup with T servers and master servers for metadata and actual data that you would use in production. You can create those setups if you want yourself, but the module is dedicated for easier getting started with testing. So it runs the Yugabyte D, which is a single utility starting both and exposing some dashboards on some ports. On the normal Mac, if you just on the Mac OS, there will be a conflict on port 7000. That's where your metrics for the data tries to bind within the container. Why it doesn't happen here is because Testcontainers doesn't map to the certain exposed ports, but it exposes in-container ports to high-level, high-value random ports to avoid the collisions between the containers themselves or anything that runs on the host machine. So when I run the Yugabyte container, it doesn't actually expose ports like 5433 or 7000, but it exposes random ports that are available and the high value. If I want to use the database now from my application, this is very easy. I can use this object to ask where my Yugabyte is running, and I can see that it uses indeed some random high-value port. So in the code, passing this configuration to the application is very simple. If I want to work with my tools, this is where Testcontainers Desktop actually has my back. It offers this services configuration, which allows me to open a very simple configuration file that would tell my Testcontainers Desktop that any Yugabyte image should expose and proxy those fixed ports to in-container ports of those values. So in-container port 5433, to access the database, I want to use 5433 on my local host. So all my tooling, like database viewers and everything, will just go with this static configuration and always get to the container running Yugabyte. And it can also expose 7001 instead of 7000, and the proxy will run without any conflicts. So with this configuration in mind, I can run my tests and I can connect to my Yugabyte. To do so, I will also use the freeze container shutdown feature. I can put it, I can enable that. And then Testcontainers will not, by default, clean up the containers. Usually it does so, and the desktop will only pause the cleanup for me currently. But the cleanup is very essential for the test. We want the test to be repeatable and run them again and again and again. So by default, when you run the containers after the test execution, they're being cleaned up and removed. If you want to debug them, or if you want to look what's happening with your database or what is happening with your other containers, you need to pause the execution. Freeze container shutdown does exactly that. So before these containers are being stopped, they are pausing. So if I want, I can use my database view from my tool or from my any other IDE or tools that you use, and I can use my stable connection port that I got from the services to connect to my database. So the connection succeeds, and we are getting into this particular database, so I can expose and work with my tables there. For example, getting the data that I put in from my schema SQL file. And when I freeze the containers, my tests will finish and go away automatically. So this is how you can use and work with your Testcontainers-based setup and create the Yugabyte containers on the fly programmatically to run your application from just code, right? I can pass this value to my tests, and they will connect to that Yugabyte, run the test, assert the behavior of my application, and then run forward. It is even a little bit easier to work with Testcontainers-based setups from some application frameworks in the Java ecosystem. Let's look at the example of a Spring application. I have my very simple Spring application. It deals with some products and prices in the database. So it binds some HTTP mappings to some functionality, and then it puts the prices in the things. The exact logic is not particularly necessary to understand. It's a Spring application, and I added the same things. I added the Yugabyte version there, so the Spring knows that it needs to connect to Yugabyte and has the driver. I added the Testcontainers YugabyteDB module, and now in my tests, for example, I can do the same thing. I will create my Yugabyte container, and I will run it. So you will not find the actual calls to start and stop in the test here. What I'm using a Testcontainers and JUnit5 extension. So the lifecycle of this container is tied to the lifecycle of my tests. I annotate my class with @Testcontainers, and my container was at container. And this means that this Yugabyte container lifecycle will be tied to the lifecycle of this particular test class. So the static field means it's one per class. The instance field would be one per particular test method. So currently with test containers and add container on the static field, it's sort of as if this Yugabyte database container would be started in a before all and stopped after all tests run in this class. So that's how we handle the lifecycle. How do we handle configuring our application to use this Yugabyte container? It's even simpler. We add the service connection, which is the Spring annotation provided by Spring Boot, and it will instruct my Spring Boot application to use this Yugabyte container instead of the static properties that could have been encoded in there. So when I run this test, what will actually happen is the container will be starting, and then the actual application will be starting, and it will wire itself to work with that container, and then it will run the test. And the test hopefully will pass because this is a sample application, of course. What is important here is that my test can be high level, like actual test. I can use my application components that need to have the complex functionality to talk to the database, not in a single maybe transaction even, but like I can orchestrate complex scenarios against the actual real instances of Yugabyte or other dependencies that I need, including to just running HTTP queries to talk to my application if it exposes HTTP to work with it in a fully sort of integration test scenario. The benefits are, of course, that the tests look like unit tests. There is no external configuration. We don't depend on the pre-provided YugabyteDB instance or anything like that. It's just literally there in the code. Any developer can edit it. I can put my breakpoints and run my tests as in a debug mode, so I can see what is actually happening there. And it's very, very easy to modify, work with, debug, reproduce both locally and CI, right? The CI, if it has access to Docker daemon, will run the same tests in the same way when you run Maven tests or your Gradle tests, which is a big, big plus because you can run your CI and you can have the ultimate confidence that your application works because it works with the actual environment that it requires to be working in production. And if anything breaks, you as a developer can very easily reproduce that locally. So even better, you don't have to use this only for the tests. What you can also do, you can use the same setup for our local development environment. So if I embed my container configuration in a configuration class for Spring, this is a Spring concept, but it's a fairly popular framework, so that's what we're doing here. You can also do this manually for your project if you are not using Spring or if you're not using any framework at all. But you need to put this a little bit of code to start and stop the containers and wire them together somewhere in the lifecycle parts of your application code. Spring Boot does it for us. So we put the containers in our test configuration, and you can see I have my Yugabyte container here, exactly the same way. I mark it as a bean so Spring knows to start and stop it. I mark it with a service connection so Spring knows to prefer that for the configuration. I also have my other infrastructure for my system here in the containers config class. And I use this container config class. I can use it from the tests. I don't have to actually write every time in every test that I need to a new container. I can use the common sort of test suite wide configuration containers. But I also can use my test application. I will create the application in my test class path to run my actual real application, but with this container config. So that means when I run my tests, I run them, they will create the environment for me with my application, with my YugabyteDB. I will be able to connect my tooling to the YugabyteDB running in the container, using Testcontainers desktop application and services. I will be able to run my, actual queries against the application if I need to run this application locally. This particular example comes with no UI, but it starts, it runs, and I can use this application if I wish to do so. A very cool bit about it as well. Remember, in our config, we exposed also the other ports like 7001 to 7000, right? So if I look, oh, you can see the application has started. If I go and look at my browser, and for example, I go to my localhost 7001, you can see that I get the YugabyteD console that allows me to explore the tables, that allows me to explore my stats, my metrics, and work with my YugabyteDB cluster in a very natural way. Thanks to the services in Testcontainers desktop, this port keeps being stable, so I can bookmark this URL and run it very naturally. Right, the application started, my containers are running. You can see if I create my terminal and do docker ps, you can see that the containers are running that I wanted to. And then I didn't have to do anything with that besides just clicking buttons in my IDE. So that's the power of Testcontainers. And let's go back to our slides. We looked very briefly at how to manage the lifecycle and container configuration in our Testcontainers-based tests. We looked at the Testcontainers modules and the Spring Boot integration. There are more things that you can look at, and there are more things that Testcontainers enables, but that was a very brief sort of high-level overview to make you sort of interested in the subject. You can hunt it and see how you can use it. Testcontainers are really great. The flexible API allows you to create any complex topologies, and we put really extra care into following the best practices for running your tests. Everything is dynamic. There is parallelization that you can do. The tests are self-contained, and it's really, really nice to work with. If you want to read about parallelization, there are projects that you can try on. There are also blog posts on the AtomicJar blog about how we run it on different CI environments, for example, GitLab, how to run Docker in Docker, and so on, what benefits the Testcontainers cloud setup works. I run my tests in the cloud. It's an edge deployment, so you can see that my cloud instance is 12 milliseconds away from me, so it's really, really fast. And in the Java ecosystem, local development support is in Quarkus or Micronaut and Spring Boot, so you can run your application locally with Testcontainers provided environment very, very easily, so you can clone and run your project and it will work without any hassle, and your whole team can do the same thing. And the Testcontainers desktop application allows you to do complex, create the services, to use the containers as if those services run locally, and it also provides you with the dashboards. So if I go to app Testcontainers Cloud, I can see exactly which containers I've been testing with. I can see exactly what was my activity. I can see what were the life cycles of my sessions and how I run them. I can see the versions I've been tested with. So it gives you quite a bit of information about that. So if you want more information, please welcome to testcontainers.com. And if you want to talk to the team or the community about your particular setup, or have any questions about Testcontainers, the Slack workspace at slack.testcontainers.org. This is where the community hanging out. So please come ask us any questions, and about Yugabyte database in particular, about any other technologies, and happy testing.